Hi everyone, great to see you today. I can see that we still have a number of people joining the call, so I will just leave it a couple more moments, then we'll get started. So I'll see you shortly. So hello and welcome everyone to the second part of our Vision to Decision webinar, and thank you for joining us today. It's great to see so many of you returning from part one and also some new faces in there too. For those of you that didn't actually see part one, you can listen to that on demand on the resources page of our website, which is viso.ai/resources. So by way of introduction, I'm Chrissy Jameson. I'm the VP of Marketing from Viso, and I'm joined again by Talia and Jeremy, who will jump on stage now from our go-to-market team. So a big welcome to you both, and thanks for joining us. We are super lucky to be working with customers who are using AI vision in live operations, and that really gives us all a unique kind of cross-industry view of how real deployments can create such an impact for them. Today, we're here to share more insights about what any of you can do to drive meaningful outcomes in production too. This session was called Vision to Decision deliberately. It's important to clarify that what we're increasingly seeing in the market can be misunderstood as a technology problem, whereas we really see this challenge as being more of an execution problem. The companies we work with and those that we talk about today already believe in computer vision, and they're making real progress in what they're doing. But as we talked about last time, they are continuing to ask us much deeper questions as they focus more and more on their journey. And we're hearing questions like, where does AI vision deliver the most value? How do we maintain momentum? How do we scale across sites without creating that operational and organizational complexity? And also, how do you make sure that what you learn through vision turns into much stronger decision making? So today's webinar is, again, far from theoretical. Everything we'll cover is grounded in kind of real implementation. So all of the companies we'll reference, from FedEx, Walmart, LG, Airbus, John Deere, and others, have already successfully deployed AI vision in live environments. Some aspects we'll cover today will reference our experience with clients on their own vision journey, and others, we just love their story. So we want to share it, but the consistent thread really is that they all have the desire to, and ambition, I guess, to use computer vision to drive their business growth through innovation. We originally pulled together a list of 10 key topics to consider, and last time we covered off the first 5. So now in part 2 today, we'll cover off the second half and then talk about how you can turn vision into that decision system. As a recap, the final 5 are robotics works, but coordination often doesn't. Inventory visibility versus inventory truth. Predictive maintenance needs context. making lean visible with vision, and finally turning vision into that decision system. So I guess let's kick off with automation and robotics. This is getting a lot of attention right now. And while we agree that robotics works, our insight really is that kind of coordination required across other processes, operators, stations, flow routes, buffers, safety systems, and those kind of work rules, I guess, often doesn't. Across manufacturing and logistics, organizations are investing heavily in robots, also cobots and autonomous mobile robots, which many of you will probably know as AMRs. But for the most part, we see those systems as designed. So why is it that throughput, safety, and stability still fall short of expectations? So I think I'll come to you first, Talia. Where do you see this disconnect most clearly when you look at these real deployments?
Yeah, so for me, one of the clearest places that I see this is in these highly automated logistics and manufacturing environments. These are environments where cycle times are really fast, error rates are low, and uptime is high. The robotic equipment does seem to be working. However, the problem shows up in between these systems. At FedEx, for example, we've seen that teams realized bottlenecks weren't caused by robots failing. Instead, the robots were finishing these tasks way too fast, and downstream stations could not absorb this work and keep up with that. So materials were arriving too early and they were sat there waiting. This meant that queues were forming, congestion was also increasing, and people started improvising unsafe workarounds just to keep things moving here. So we hear this really, really extensively at logistics conferences that we've been to. Early automation investments delivered local efficiency gains, but system level throughput didn't improve proportionally because handoffs between automated work and manual zones created a lot of friction for these teams. So once they applied vision across their entire workflow, not just for monitoring individual assets, but observing how work moved through the entire system, they could see congestion building before it caused these stoppages. So FedEx specifically used this insight to rebalance work dynamically. And this meant that they needed to slow down some processes and accelerate others. As a result, the redesigning handoff points between humans and machines and adjusting buffer sizes meant that throughput was then improved. They saw that congestion dropped and safety incidents related to rushed workarounds actually decreased quite significantly.
As always, that's a great summary, Talia, and I love that FedEx example. If it's all right for me to jump in here, one of our global logistics clients shows a similar story in areas like parcel routing and warehouse operations. They deployed vision, though, not just to validate package sorting, but really to understand flow dynamics. And what they discovered was that small mismatches in processing speed between stations created this, what I'd call cascading effects. So that's starvation downstream, congestion upstream, and increased safety risk as workers rush to compensate for these kind of bottlenecks. So what Vision really does by visualizing these interactions, not just monitoring whether individual systems were running, but how those systems were affecting each other, they were then able to redesign things like task sequencing. That means adjusting staffing allocation as well, and also reconfiguring layouts. So the important point is that the robots themselves didn't change, but as Talia referenced, throughput and safety both improved significantly because the system was optimized, not just the components. And then I'd also add that in a manufacturing context with mixed automation, we typically do see the same pattern again. Vision reveals that the constraint isn't the robot cycle time. It's actually more about the time lost in handoffs and waiting and rework, all caused by that misalignment between automated and manual stations, or by safety pauses caused by that congestion.
Yeah, that makes sense. Thanks both. I really think like the key outcome and insight we consistently talk about here is that the teams stop optimizing individual machines and they start optimizing systems. It looks to me like they get more output, fewer stoppages. I think you both referenced safer operations, better utilization, I guess, of existing assets. So it's not buying more automation that moves the dial. The ROI really comes from that coordination, not from more or faster robots, I guess. Okay. So I'd like to shift to an area where most organizations believe they already have this strong visibility. And so theme 7 addresses inventory visibility versus inventory truth. So most major organizations today have these sophisticated inventory systems, real-time tracking, scanning dashboards, reports, etc. But on paper, this inventory is visible, but operation teams are often still surprised by shortages, damage, or even stock that kind of exists, I guess, on the system but can't be found on the floor. So, Jeremy, maybe you can tackle this. What's going on when inventory visibility doesn't really translate into inventory reality? And I guess what can be done about that?
Sure thing, Chrissy. Thank you. Some of my research recently looked at Maersk's operations, where vision was already deployed across yards and warehouses, distribution centers, all the usual places. They already had pretty much world-class tracking systems, so they knew what inventory should exist. Exactly to your point, Chrissy. They could generate reports by SKU, by location, by value. But what vision revealed was that inaccuracies weren't primarily system errors or data entry mistakes. They were actually more behavioral and environmental. Items were being damaged during specific handling steps, for example. Fault movements that were too aggressive, or stacking patterns that ended up creating crushing. There was stuff like exposure to weather during transfers, or materials being blocked by a poor layout design. So that made them physically inaccessible, even though the system said that they were available. So items were misplaced during congestion peaks when workers were rushing and then didn't have time to scan properly. None of that showed up in their traditional inventory data. The system was accurate about intent or where things were supposed to be, but vision revealed reality. That's the inventory truth. And that's where things actually were, and crucially, what condition they were in. So I'd just like to say that by using vision to observe how inventory actually moved, how it was handled, what happened during peak periods, operation teams there were able to redesign storage layouts to reduce damage. They were also reconfiguring traffic patterns to eliminate congestion choke points and adjusting handling procedures to prevent misplacement. So inventory accuracy improved not because the counting got better or because people scanned more diligently, but because the processes that were creating those errors at source were fixed at the root cause.
Yeah, those are all really great points, Jeremy. And I'll jump in to kind of piggyback off of that. And just say that we're seeing so many large retailers who are actively exploring or deploying computer vision to automate their inventory tracking, thus to improve operational efficiency. And so one of the most visible examples of this is actually Walmart. So they use AI-powered systems in select stores, and this is to monitor inventory, which will reduce the stockouts in real time. So they can automate self-checks, they can verify stock levels, and also maybe even validate something like exit transactions. And so for them, this really increases and creates efficiency gains. The real value here, however, is that when the teams analyzed why items were missing or misplaced, they ended up discovering patterns that were tied to store layout. So this could look like maybe certain aisles had shrink because of sight lines and because of traffic flow. And with this, they found time-based patterns. So stock discrepancies spiked during peak hours when restocking teams were really under pressure. So they identified product categories where packaging made items vulnerable to damage during handling. So acting on these insights, they didn't just count more often. And this is like a really crucial point here. They ended up using this information to then redesign store layouts, which helped them improve visibility in high shrink areas. They also adjusted restocking schedules, and this reduced time pressure. And then ultimately, they also changed packaging specifications for these vulnerable products. Because of this, the shrink ended up decreasing. On-shelf availability also improved. And on top of that, inventory accuracy increased. And this was all done without adding buffer stock or increasing labor.
Yeah, thanks, Talia. That is pretty incredible. And essentially what we're seeing is that these inventory problems become explainable and fixable, right? Instead of being these constant recurring mysteries that everyone suffers. We also see the need for safety stocks kind of reducing, the accuracy is improving, which ultimately means less capital tied up in those inventory buffers that you referenced. I think it's also super interesting to see production or fulfillment delays caused by these unexpected shortages where I guess the system says inventory exists, but it can't be found. And all of those largely disappear. So it's really good to see that these teams really move from constantly reconciling systems to achieving that kind of genuine operational truth that you mentioned, Jeremy. Okay, so on to our 8th theme, predictive maintenance. So why does this need context? I think it's been a major focus for years for many, many companies, yet results are often still quite mixed. We hear that despite alerts occurring, decisions are often still hard to make, and it seems that teams can sometimes really struggle to know when to intervene and when to wait. So let's go back to you, Talia. Where have you seen vision make the biggest difference in kind of turning signals into confident maintenance decisions?
Sure. Happy to take this one. So LG, for example, when compared to most consumer electrical giants, they saw that predictive maintenance relied heavily on traditional sensors, which is really, really common in this sector. So these sensors included things like vibration analysis, temperature monitoring, current draw, and acoustic signatures. And they saw that those systems were good at detecting anomalies, and when something changed, an alert would trigger. Simple. But maintenance teams still typically struggle with 2 problems. The first of those problems being false positives. So sensors can often flag anomalies that turn out to be normal operational variation. These are not actual failures. So on top of that, the second problem is just uncertainty. And so even when an anomaly is real, many teams don't always know why it's happening or whether it actually does require immediate intervention from the part of the team. So by adding vision to their predictive maintenance program, maintenance teams with LG, they were finally able to gain this context. So when they saw that a sensor alert was triggered, they could visually assess what was happening in real time around that equipment. Maybe there was a visible leak explaining the temperature change, or had something come loose or misaligned. Maybe even environmental conditions were different. There were tons and tons of scenarios that they really needed to dive into that just weren't clear without the intelligent visual aspect. So these confirmations from the system changed their decision-making dramatically. And this is something really, really key in that, yes, the system does uncover these patterns. It gives teams more insight into what's happening. But in order to fix these challenges, behavioral change is just so necessary. And this is a great example of that, because teams stopped treating every single sensor alert as equally urgent. They could distinguish between real wear that actually required like this immediate action, or temporary operating conditions that were safe to monitor. But even, of course, the false alarms that could ultimately just be ignored. So the maintenance became highly targeted and timely, and it wasn't just cautious, and they didn't have to actually just cease production for every single alert. So alternatively, it risked becoming dangerously delayed and ignoring alerts until something actually broke. So what LG has discussed is that this integration of vision and sensor data ended up reducing this unplanned downtime. It really extended the life of their equipment, and it made maintenance labor far, far more productive because technicians were getting to use their time well and they weren't just chasing false alarms.
Really comprehensive and insightful as always. I'd looked into some in electronics, but also outside in aviation and energy, for organizations like Airbus and some major utilities. Vision plays a very similar validation role to that which Talia described. A key point to emphasize is that vision doesn't need to replace the sensors, rather it complements them. So vision also catches issues that some sensors might miss entirely. And that could be gradual corrosion that doesn't affect vibration or temperature until it's severe. Another example might be developing leaks that are visible before they're thermally significant, or loose components that haven't started vibrating yet, but will soon. Maybe unsafe operating behavior, could be equipment being used outside of its design parameters. All these are kind of things that sensors just can't detect. But at Airbus, they use computer vision extensively in assembly, in quality control, and crucially predictive maintenance. And teams have talked about vision providing what they describe as the human eye at scale. I quite like that phrase. And this is the ability to see developing issues the way an experienced technician would during a walk around, but continuously and across hundreds of assets simultaneously, all at the same time.
Yeah, that's some really great examples here. Thank you. I guess in a nutshell here, downtime really decreases because failures are caught earlier and with greater confidence, right? Those maintenance resources are used more efficiently because teams aren't wasting time investigating these false positives or conducting unnecessary preventative maintenance too. And then ultimately, the equipment life extends because problems are addressed before they cause secondary damage. And perhaps most importantly, teams gain confidence in their maintenance decisions. And it seems pretty clear that they're not guessing whether an alert actually matters. Instead, they're just, they can truly see whether it does, and then they can act accordingly. Okay, so into the home straight now. Our ninth theme is how vision and visual intelligence makes lean visible. So lean tracks KPIs like OEE, cycle time, and throughput very religiously. Yet when performance varies or problems emerge, teams still spend a lot of time debating what's actually happening. Computer vision changes that dynamic by showing work as it truly happens, not just how it's reported. So, Jeremy, how does that shift play out in real lean and continuous improvement programs?
Yeah, thank you, Chrissy. I mean, I love a metric or KPI discussion. And KPIs like OEE tell teams what has happened. So the output was 85% yesterday, 78% so far today. And those KPIs don't, however, shed any light on the why. That's the most important bit, right? In several manufacturing deployments that we've supported, vision revealed waste that never actually appeared in any system data at all. So that might have been micro stoppages that were too brief to get logged. One that I remember was informal workarounds that operators developed when their standard process just didn't quite work. Then there was wasted motion, such as extra walking, unnecessary handling, things that crop up like searching for tools or materials, and any kind of inconsistent task execution where different operators quite understandably did the same job, but in fundamentally different ways, some of them efficient and some of them wasteful. What's key is, as with these examples, once teams can see these behaviors on video, then those improvement conversations around lean are really transformed. Instead of it being a debate, a bun fight about opinions, I think the problem's X, or, actually, I think it's Y. What AI vision delivers is actual real clarity, enabling teams to move to objective evidence. You can literally watch the waste happening. you can measure it and quantify and then see its frequency and its impact. Organizations who are deploying lean programs, this has the potential to change, well, pretty much everything. Waste identification becomes faster and, importantly, undeniable. The ability to build clear insights, to truly understand where the challenges lie, can then arm that organization with the power and the data to make the required changes quickly and easily. Improvement becomes more collaborative because everyone can quite literally see the issue clearly. And dashboards are then very simple to incorporate into the systems, all systems use today. And the insights that are gained can then be actioned and used instantaneously.
Yeah, that's really great, Jeremy. So I also, of course, firmly believe that lean really does show the power of AI vision. And what's really, really powerful here is that these improvements can be verified just completely visually. So after a layout change or like a standard work update, a Kaizen event, teams can see whether behavior does actually change. And this is what I was mentioning before with the real power of the behavioral change within the firm. So did the new process actually reduce motion waste? Are operators actually following the updated standards? What's going on with the bottleneck? And these verifications really end up preventing regression. And so in traditional lean deployments, improvements can fade over time and people will drift back to old habits. But with vision, with intelligent systems, this drift becomes visible almost completely immediately. And so teams can really see when compliance starts slipping and in real time start to intervene before any improvement is lost. And so we've seen this work really effectively across automotive manufacturing, with our food processing clients and electronics assembly. So teams implement these changes and they can verify whether they've actually been working and functioning. And this is through really strong visual evidence. They sustain those changes because drift is visible. This is such a core fact that things are brought to light, which results in the behavioral change. And ultimately, this compounds improvements over time because each change is really able to stick.
Yeah. It's fair to say, really, that lean becomes faster, more objective, more collaborative, all with the help of computer vision. I think teams spend less time in conference rooms discussing those root causes and more time actually on the floor fixing them. And like you say, Talia, improvements stick because compliance is visible, it's verifiable, and the pace ultimately of that continuous improvement accelerates because evidence replaces opinion and verification kind of prevents that backsliding. So all super, super interesting stuff. Right, so time to round out our session today and our final theme, I guess, or hope, the one you've all been waiting for, which brings all of these things together, which is turning vision into a decision system. So many organizations have succeeded in deploying vision. They're detecting issues, they're generating alerts, they're producing dashboards. The real question we need to address is what happens next. So when vision sees something, does the organization actually decide and act, or does the insight stall? So Talia, I'm going to come to you first. What does it look like when organizations truly close that loop?
Yeah, so also super excited to round out these sessions. And I hope as we've lifted the lid on both today and in the part one, we have seen so many organizations that have successfully deployed these intelligent vision systems. So they're detecting the issues, they're generating alerts, producing dashboards, and then ultimately these very visual reports as well. And this creates the visibility, which, as we've really driven home this session, is so valuable. And so for us, and like what we ask the companies, what they want to know with these reports is like, what happens next? So in most deployments, someone reviews the alert and they decide whether or not it's urgent. If it is urgent, they contact another team. That team evaluates, prioritizes, and then maybe decides to schedule some action. But in this time, the issue could have worsened, and it also could have spread to other areas. And so it also could have resolved itself through manual workarounds. So maybe not the best course of action, but the organizations that we're working with have really been achieving great breakthroughs at closing that loop. So they're able to connect vision directly into their workflows and directly into their decision systems. And so when these intelligent vision systems are able to detect a maintenance issue, it doesn't just send the alert. It automatically creates a work order in their computerized maintenance management system, or the CMMS. So the CMMS is then able to assign the appropriate technician based on the issue type. And this is what provides the visual evidence attached to the work order. And this is what tracks that issue resolution. So when the vision system identifies any safety risk pattern, and a common one is, of course, near misses. This could be in a specific area or during a specific shift. It doesn't just flag that on the dashboard. That's just a small part of the picture. What it does is triggers retraining for the affected team. It can schedule a safety audit. It could adjust supervision in the area. And then it can also notify the leadership with visual context. So when vision spots quality drift, it doesn't just wait for someone to notice a dashboard trend. And this is why we really drive home the point of augmenting someone's position. It's essentially more power given to the HSE people working on a team. And that's why it alerts the line immediately. It can help adjust process parameters automatically where that's possible. And of course, it can notify engineering if this manual intervention is needed.
Fantastic. I hate to be that guy that tries to get the last word, but I guess I'm going to be that guy and bring in my favorite example as we round this out. It's a really powerful example, and it's a real world deployment from John Deere's See & Spray, which doesn't just detect the weeds that are there in crop fields. It goes a lot further and triggers targeted application of herbicides in real time. So the decision to spray happens automatically. That's all standard and at machine speed, but it's based on visual detection. Farmers have actually reported that they can reduce the amount of herbicide they use by anything from 2/3 all the way up to about 90%, because the spraying's only targeted where the weeds exist and not broadcast scattergun across entire fields. Another example in logistics, vision outputs are deeply integrated into warehouse management workflows. So when vision detects package damage or missorted packages or any of the safety risks that can come up, these detections don't generate emails for someone to review. They trigger an immediate routing change, a quality hold, or whatever type of safety intervention is already built into the process. The system can truly act on what it sees. And finally, bringing back in the example of Airbus just before, vision integrated with assembly workflows actually validates that components are installed correctly before allowing the next assembly step to proceed. So the workflow actually can't continue until visions confirm that quality. And what this does is it embeds quality assurance directly into the production sequence instead of treating it as a separate inspection step. Really powerful.
Yeah, nice, very nice. Yeah, we definitely see response times shrink from hours or days to seconds or minutes. And we also see that actions become consistent regardless of who's on shift, so which supervisor is working or how busy the team is. Seeing human effort shift from monitoring dashboards and deciding what to do to actually handling those exceptions and improving processes is just brilliant. Most importantly, improvement compounds over time because the feedback loop is closed immediately. Problems get fixed faster, patterns are identified sooner, and knowledge becomes really embedded in workflows automatically instead of depending on individuals remembering those lessons learned. And there's always someone somewhere that's, it's in their brain, So computer vision, I guess, becomes something that actively manages, actively improves operations autonomously. And that's when the ROI accelerates and organizations move from incremental gains to that true transformational change. So a big thank you to you both. I'm mindful of time, so I will move to questions we have from our audience. Please do keep them coming in. Any that we don't get to immediately, we will reach out directly to you after the webinar and answer you personally, of course. Okay, so let me take a look. Okay, one to start with. How do you decide what should be automated versus what should stay human-led, especially in safety and maintenance? So maybe, Jeremy, can I come to you for this one?
Thanks, Chrissy. Great question. Let me think about that. So I guess for me, it comes down to two things: consequences and then reversibility. If the action is quick and low risk and time sensitive, so diverting a damaged parcel or maybe easing a congested process, then it's a no-brainer to automate it. If there's real judgment involved, then yeah, keep a human in the loop. And for anything with really serious consequences and ramifications, it should stay human-led, full stop. I think it's important with all of these areas to just state that the goal isn't to remove people from the picture. It's actually to free them up and prioritize for the decisions that actually need them.
Yeah, very smart indeed. Okay, next up I've got, maybe I'll come to you for this one, Talia. How do you avoid computer vision becoming just another dashboard where interest drops off, after a few weeks?
Yeah, so how can we avoid computer vision just becoming another dashboard? This is a good one, actually. So for me, I've seen that dashboards can fail just when they're optional. So we've seen adoption stick when vision is embedded into the daily management system. So with the right integration, you kind of make it impossible to ignore. And dashboards die when they're optional. So again, the ones that stick are embedded into things that people already do, like what they're already using. So shift handovers, safety briefings, meeting planning. And I guess like we can't really forget that detection has to lead somewhere. So it's not just the act of seeing like, okay, this person is not wearing any PPE. Like this needs to trigger all of a process downstream. And so if it doesn't create an action with an owner, it's just noise. It's just a tool that's essentially not being used instead of a really valuable infrastructure for the team, for the firm. But when it works well, it works really well, and it becomes part of how the team operates and almost like a team ethos.
Yeah, absolutely. Absolutely agree there. Thank you. Okay, another one here around scaling. Okay, so I'll bring this to you, Jeremy. So we've proved value at one site. How do we scale across multiple plants without creating too much complexity and costs ballooning out of control? I think we may have just lost Jeremy. Maybe we'll come to you with that one, Talia, instead.
Sure. Sorry, can you repeat that just one more time for me?
Absolutely. So we've proved value at one site. How do we scale across multiple plants without creating too much complexity and costs ballooning out of control? So yeah, if you want to take that, Talia, that will be great. Hopefully we'll get Jeremy back.
I see Jeremy is back now, but I can definitely answer this.
Yeah, you take the question.
Yeah, so this does make perfect sense. I would say maybe right up front, you just need to think about the platform that you're purchasing. You need to think about like what's really a good fit for your firm. What do you need right now? What does your team need right now? Can it consistently layer, I don't know, new use cases? Can it scale across multiple sites? That's a big one we always see, starting at one and then expanding to many. And can the tool that you want to use or the infrastructure or platform, does it all use the same dashboard? Does it all use the same incident center? So the trap beyond that essentially is just letting every site rebuild from scratch. So different integrations, different rules, different days of working. And I would say with that, that's where we've really seen that costs can balloon. So the organizations that scale and scale really well, they're able to lock down 3 things early. And I would say this would be the platform setup, decision playbooks, and how learning gets shared across sites. And so getting those very, very consistent, and each new site becomes faster and cheaper than the last. It doesn't become more difficult to implement. So this consistency, of course, is key, and it makes the potential to scale completely predictable. Here we've seen that costs stay linear, adoption is pretty fast, and ROI compounds. And this is essentially because each site can benefit from network learning.
Yeah, that's brilliant. Thank you. Maybe I'll come back to you then, Jeremy, for this last question. So you really will get the last word for dropping out. But okay, so this person says, I get the theory, but what does a decision system actually look like in practice? What are the components we need to have in place to make this truly work effectively?
Thanks, Chrissy. I know I'm going to get some grief for ducking the last question and leaving that to Talia. So thanks for bearing with the technical problems. But I'm back. Yeah, so what a decision system looks like in practice. A few components, really. I think you've got a few things that are working together. What outcome you're after, your detections being reliable, I'd say every signal that has a clear owner and response, all of that is wired into your existing systems and tools. And there's a feedback loop, so it just keeps getting better. When all of that's in place, you stop reacting and then actually you start managing for real. And that's when it shifts from being a reporting tool to something that can genuinely run huge aspects of operations and a management layer rather than a reporting layer. How's that?
Perfect. Thank you so much. Okay, so I think that's probably all we've got time for today. So a big thank you to you all for joining. And again, my thanks to Talia and Jeremy. As ever, please do feel free to reach out with questions that we didn't have time to get to, or any other questions you might have, and we'll get back to you as soon as possible. Just a shameless pitch. We do have a new webinar series coming from next month. We've called it In Plain Sight. It's focused on practical tips and advice around computer vision. So look out for your invitations coming through for that. Also, please do keep an eye on our LinkedIn page for more details in the coming weeks about some events and some meetups and some community sessions we will be running in various locations. And then finally, I guess, if you need any practical help, check out our health and safety toolkit on the resources center in the resources section of our website. So thank you so much for tuning in. Great to have you all here today, and we will see you next time. Thank you very much. Bye-bye.